Welcome to Maths and Science by IITIan channel. In this particular lecture, I want to give some advanced topic introduction in matrices. It's out of box thought. It's not a regular syllabus. It's an out of box thought from my side to provide some amount of insight into the matrix power series. It's not for regular syllabus. It is for advanced studies. Matrix power series. And this in matrix power series, let us think. We have lot of examples: e to the power of e to the power of something like I, e to the power of e to the power of up to infinity, e to the power of sin x. Many things we have done. Please look into my previous lectures for understanding this. And can I put e to the power of some matrix? Is it possible? Can I put e to the power of some matrix? Is it possible? That is the question here. If I put e to the power of some matrix, what it means? Matrix is not a number. It's a matrix. Then can I use as a power e to the power of some matrix? Let us try to, it's an out of box thought. Let us try to delve into the subject. E to the power of a is equal to, if a is equal to e to the power of a is a power series of matrix, where a is equal to a square matrix. It can be of m by m or n by n, where m and n are arbitrary numbers. Size. It's a square matrix. If it is a square matrix, then it is defined, the value of e to the power of a is defined as sigma n is equal to 0 to infinity a to the power of n by factorial n. This is the meaning of e to the power of a. What happens if n is equal to 0? If n is equal to 0, it becomes e to the power of a is equal to a to the power of 0 by factorial 0. That is equal to I. Identity matrix. You just see, if somebody asks you in an examination like JEE Mains, JEE Advanced, or in Maths Olympiad, and ask you to define what is the value of e to the power of a, if n is equal to 0 means it is an identity matrix. What is the value if n is equal to 1? Just see what happens to this series. E to the power of a is equal to identity matrix for 0 plus a to the power of 1 by factorial 1. That is equal to I plus a. If n is equal to 2, this becomes e to the power of a is equal to I plus a square by factorial 2. Similarly, it goes on, and e to the power of a is equal to I plus a square by factorial 2 plus a cube by factorial 3 plus and so on. For example, if in this series, this is power series of a matrix or e to the power of matrix. E to the power of matrix here. This is defined as I plus a square by factorial 2 plus a cube by factorial 3 and so on. Then if A is equal to Pauli matrix. I have already informed you or explained you about the Pauli matrix in one of my lectures. Very important matrix as far as quantum mechanics is concerned, modern physics is concerned. Pauli matrix. If A is a Pauli matrix, then what will be e to the power of, it is a homework for you, please do it on your own. I have given the definition. It is a out of box lecture for increasing your thought process about matrices. As a homework, if I give you e to the power of I into sigma is the Pauli matrix. You take any Pauli matrix, sigma 1, sigma 2, sigma 3, anything, 3 Pauli matrices are there. I sigma theta is equal to what? This is the question I am going to pose to you, and please try to solve this so that you will get an insight of what is the use of matrices, why we are studying matrices. That for quantum mechanics, physics. In physics, something like a question comes like on a Pauli matrix means you will be easily able to understand from these basics that Pauli matrix e to the power of I sigma theta is so and so. And I have already explained you what is a unitary matrix and what is a Hermitian matrix. You know about unitary matrix and Hermitian matrix. Please refer to my previous lectures for the definition of these. I want to give another homework to you. Prove that unitary matrix is equal to e to the power of I into Hermitian matrix. This you take it as a homework and prove it. That means complex number matrices, different matrices like your Pauli matrices, which are also complex numbers, I0, 0 minus I, which we have done in our previous classes. 1 0 0 minus 1. Traceless matrices. Traceless matrices. They are Pauli matrices. If I want to define e to the power of a Pauli matrix or e to the power of I into Hermitian matrix, and e to the power of any matrix for that matter A. There are 12 to 13 types of matrices which I have explained to you in the previous classes. Please refer to them. Hermitian, skew Hermitian, symmetric, skew symmetric, singular matrix, non-singular matrix. And these are the different types of matrices. For example, this is out of box thought process and out of box, out of your syllabus. It is only out of my interest I am explaining you how matrices can be used. You have Pauli matrices. Please do something for Pauli matrices, something for Hermitian matrices, something for general matrices. Please solve e to the power of something. What happens to that? And these are the different types of matrices. We can even have exponential to the power of matrix. For example, if you say some Pauli matrix, if you take what is the Pauli matrix? Traceless. 1 0 0 minus 1. I told you just now. What happens e to the power of 1 0 0 minus 1? Can you prove it to be e 0 0 e to the power of minus 1? Can you prove this? Prove this. Try to prove it from the definition what I have given you. That means the applications of matrices and in data sciences, computer science, artificial intelligence, data sciences, and even in applications of computer science, engineering, we get this type of matrix problems and we will be solving them and we will be getting from the definitions the values. This is a little bit advanced topic. The meaning of matrix is a power series is also a good meaning, and from this we can go for what you call diagonalization of the matrices, which is one of the very important topics and advanced topics for computer science engineers and also for data science engineers. For example, one good example I will give and I will close this topic. A is equal to, let us say, some A 0 0 B, a diagonal matrix. Then e to the power of A is equal to e to the power of a 0, 0 e to the power of b. Just think over, try to solve it. It looks very simple. Prove this from whatever I have given you. Definition of e to the power of a. Is it not looking very simple? If somebody gives a question, e to the power of a is what? If a is equal to a 0 0 b, then e to the power of a is equal to e to the power of a 0 0 e to the power of b. And if you want to go for rotational dynamics, there are rotational matrices. In that also, in rotational dynamics, this particular type of matrices are used for understanding and feeding into the machine for getting the better output. Ultimately, data sciences, computer science engineering is everything is nothing but collection of a data, giving some input and getting the required output or getting some output with internal formulations done by the computer. With this intention, I have given this lecture and I explained you. You try to prove this e to the power of a, capital A matrix is equal to e to the power of a small a 0 0 e to the power of b, provided capital A the matrix is a 0 0 b. This is one. And you also try to prove e to the power of 1 0 0 minus 1. Just to see e to the power of, if a is equal to a Pauli matrix like 1 0 0 minus 1, then what is the value of a here? A is equal to 1, b is equal to minus 1. That implies from this, what we have done, e to the power of a is equal to e to the power of a 0 0 e to the power of b, that is equal to e to the power of 1. A is 1, 0 0 e to the power b is minus 1. This is nothing but e 0 0 e to the power of minus. If this can be proved, e to the power of a is equal to e to the power of a 0 0 e to the power of b, then automatically a can be, if Pauli matrix is used, then that values can be substituted and we get b. That means indirectly, directly we have already proved this one. This one we have proved. And for other Pauli matrices also you can easily prove. And this is what it is used in many engineering applications. Then I thought it will be prudent for me to give an introduction of this. Ultimately, I will conclude with the formula e to the power of a is equal to sigma n is equal to 0 to infinity a to the power of n by factorial n, that can be written as I plus a plus a square by factorial 2 plus a cube by factorial 3 and so on. This is power series of a matrix, and from this we got some two good results. One is, if a is equal to a 0 0 b, this implies e to the power of a is equal to e to the power of small e to the power of a 0 0 e to the power of b. This is a very powerful result. You can try for any matrix, whether it is a Hermitian matrix, whether it is a unitary matrix, whether it is a diagonal matrix. This type of matrices are called diagonal matrix because we do not have any other elements except in the diagonal matrix. For a diagonal matrix, e to the power of a is e to the power of a 0 0 e to the power of b. Thank you for listening to me. I will stop here. Beyond that, I don't want to go. This much is sufficient for you. If any this type of question comes, or indirectly if a meaning is given like this, in the examination there can be, examiner can say e to the power of a definition is so and so. Then if a is equal to a0 0b, what is the value of e to the power of a? Then don't get confused. This is the value of e to the power of a. And sometimes what happens, they give the definition which is unknown to you and they ask you from the definition to derive certain answer. Hence I thought, okay, it is prudent for me. It is a matrix which is being used in the sciences and engineering, and especially in quantum physics, quantum mechanics and modern physics. Then I thought it is prudent for me to define this. Thank you for listening to me. Thank you for viewing my lecture. And if there is a value addition to you because of this lecture, please share my video and please subscribe to my channel